time I try to debug my mind, my code's a riddle, you always rewind. You find the errors in every nested loop. Oh, clever llama, master of the code. You solve our mysteries just like I was told. VFDs and VLCs, you know them well. Edging my secrets.
Welcome back. In today's video, we're going to talk about the start absolute index and actually start doing some motion control. Here is the code that we're going to be working with today. As you can see, it's a single block. The block's name is start index absolute. This block is part of the AMC template, and you can find these blocks over here on the right side that come with the template system. Now you'll notice that it has a digital output. Basically, all this digital output is doing is if the drive isn't active, it's going to throw an error. So I'm just going to delete it because I don't need it for my test today. To find out more about each of the inputs, you're just going to take your mouse and hover over them. It will give you a fairly clear idea of what each of these inputs are used for. Just to give you a basic idea, acceleration is the rate at which it speeds up to the commanded velocity, and deceleration is the rate at which it slows down to zero speed. And so here you can see that the deceleration is 2 times faster than the acceleration. Now you'll notice that the position, I have this little word in front of it called POS. This is just a variable up here at the top that I'm going to use to edit this value dynamically. So let's go online with the program. From this point forward, all we're going to do is show this piece of code, and I'm going to go through a couple different questions for you to think about, and we're just going to simulate them with this illustration at the bottom. Are you ready? Let's say we're at position 0, and we tell it to go to 10,000. What happens? Well, you can see we went to 10 inches. Why 10 inches? Well, that's because the user units are set up so that it has 3 decimal places. Now, this could be set up differently. It could be 4, 5, 6, or 2, or whatever. That's set up with a different block. We talked about that in a video earlier than this one. But for this one, just note that 10,000 equals 10 inches. So we're still at 10 inches. So what happens if we start it again? It didn't move, did it? That's because we're already at position 10 inches, and that's where we told it to go. Cool. So you can pretty much see that all this block does is go to the position you tell it to. In this example, we're at 0 position, and we start it. And then we're going to start it a second time right here at 5 inches. As you can see, it still went to 10 inches. Cool. What if we do that same thing, but we change the position? What happens then? Okay, we're back at 0 position. We start it. You can see we're headed to 10 inches, and we change it to 20 inches. And it went to 10 inches. Why is that? That's because this started contact here is a positive edge. We didn't trigger it again, right? But if we would have triggered it again, it would have just gone to 20 inches. And so you might say, why use the positive edge contact in front of the block? Well, for this particular block, it is not important. You can use a standard contact, but I like for people that are new with these blocks to use this positive edge contact, because some of them you can't use a normal contact because it'll cause the system to crash, okay? But for this one, it's perfectly okay to use a standard contact because you're telling it to go to the position you want to go to, which also lends itself to changing the speed and acceleration dynamically, which can be useful for some applications. Thank you for watching. If you enjoyed this video, you might want to watch the next video. The next video is about start index reference.